Okay, where do we stop going around the room? Danny, you're next. C2H6, ethane. Daisy? Butane. Dwayne?
Heptane.
Brian?
Decatane?
Yeah, it's not decatane because we don't add a T, it's just decane. We say deca, but we just drop that extra A. You're going to see a lot of these names. You're going to have trouble pronouncing them, and sometimes we'll have two things that are spelled the same way and we pronounce them differently. Like periodic and per-iotic. They're spelled the same way. But we put the accent on a different syllable, and it means something different to us, right? So now, think this one through, Shane. Octa, deca. What's octa? And what's deca? What's octa, deca? You got two choices in my mind. Either 80 or 18, right? It's 18. So C18. So if I have 18 carbons, how many hydrogens do I have? 38. How about hexadecane, Morgan?
C16. I don't know.
Okay, 2 times 16
Oh,
plus 2,
oh, 34.
34. So on the test, when you have to write these out, if you remember that, you'll be able to write them out. Think of the name and what that prefix means, how many carbons, and then you can figure it out.
How do you tell the difference between if it's like an 18 and like an 80?
Well, we're not going to have anything more than 10 for this class, but when it gets to 80, they name it differently, and I don't know what it is. I'd have to go look it up. Okay, I haven't really studied. It's what?
20 is like infinite, I think.
Yeah, they got weird things when they get longer. And I haven't taken an organic chemistry class since 1973. So that's not really my thing. Okay, so now we've looked at another set of rules. And again, everybody did really well. You were able to breeze through those, naming them, following the examples. But being able to do this later when you've got them all mixed up is not easy. It takes a lot of practice. So now we're going to leave that and go on to another set of rules. This set of rules is for involving polyatomic ions. Now, I've been hounding you to practice this for a while already. Some of you have, some of you have been relaxing. But polyatomic ions are made from covalent bonding of more than one atom together to make an ion. Now, we still have differing numbers of protons and electrons, so we have a charged species, or we have an ion. And these form ionic compounds the same way as monoatomic ions do. Cations and anions come together, and they neutralize each other. But now that charge is shared across the polyatomic ion, or an aggregate. But that has nothing to do with anything. You just name them the same way, you write their formulas the same way. In order to do that, you have to be familiar with the polyatomic ions. Now, here's a few we're going to talk about, but these are mostly on the list I gave you. Ammonium is NH4+, and that's really the only polyatomic cation we're going to use very much in this class. The hydronium ion is on the list in your book, but that's just a hydrogen ion in water. We'll talk more about that later. And we don't make compounds from the hydronium ion. Ammonium will make compounds. And the other polyatomic is that weird mercury 1, or the mercurous that we've already talked about, because it has 2 mercury nuclei, even though we call it mercury 1 and it has a 2+ charge. So it's really these two are the ones that we'll deal with in class. Now, there are many polyatomic anions in the world. And these polyatomic anions come from acids. So their names are related to the acid names. Now there's philosophy. You can memorize the ions and then figure out the acids from them. That's my philosophy, and that's the way I teach. Or if you know the acids, you can figure out the anions. And if you happen to know sulfuric acid, H2SO4, then you know sulfate, SO4, it has a 2- because there's 2 hydrogens in sulfuric acid. So you can go either way, but most traditionally people learn the ions first and then the acids, and that's how I'm going to approach it. So these oxoacid anions are named using the root name of the nonmetal and the suffix ate or ite. Ate means more oxygens and ite means less oxygens. So I've listed a couple of pairs here for us to look at as examples. I have CO3 2- and CO2 2-. This is carbonate because it's got carbon in it. This is carbonite. You see that they have the same number of carbons, 1. They have the same charge, but they have differing numbers of oxygens. Now, this says it's imaginary because we don't see the carbonite ion appearing in nature. We have carbonic acid, but when it decomposes, we don't get the carbonite ion. Okay, it breaks down and gives us carbon dioxide. So that's why it's imaginary. Okay, let's look at these two. With sulfur, sulfate, sulfite. Now, in this one, we've got 4 oxygens for the ate and 3 for the ite. Here we have 3 for the ate and 2 for the ite. So you have to study, practice, learn which nonmetals form these multiple polyatomic ions and how many oxygens there are. It's a lot of stuff to practice, study, learn, memorize, which is why you want to start earlier rather than later. So go ahead now, take a minute at your seats, and I've put the pairs together for you. So you can go ahead and name those pairs.